Alright, so this is going to walk you through Summon 5, which is the Ibeam model. So we are going to be modeling an Ibeam, and we're going to do some stress tests on it. So we talked about doing stress calculations on just a cable under tension. That's a very easy case because it's just tension, super easy to do. But if we have something like a beam that's under a bending moment, that is far more difficult to do mathematically. So what we're going to do is actually do an FEA analysis, a stress test, but before we have to do that, we actually have to model it. So I'm going to show you guys how to do that. So we're going to do this in Fusion because Fusion is much better at doing static stress tests. So you can do them in Onshape with third-party programs, but it's just much easier to do it in Fusion. So we're going to be doing that. So here we are in Fusion. And there's a couple things we want to make sure before we actually get started. And the first is that we are in the correct unit. So if we go to document settings, there's this little arrow right here. We can see I'm in inches and ounce mass, which is, yeah, that's fine. So I need to be in inches. So just make sure that you're in inches because this beam that we're going to be building is imperial, imperial uses imperial measurements. So yeah, it's going to be in inches. All right, the other thing we can do is make sure that our environment is set up correctly. So I know you guys are probably used to Onshape. So if we go to over here, click on your little icon with your name, and we'll go to preferences and make sure that you have Tinkercad set to your pan, zoom, and orbit. That'll be the most like Onshape. So orbiting around, rotating, zooming, panning, things like that. And I also like to reverse the zoom direction, which means if you scroll up, it zooms in, you scroll it down, it zooms out. So that's going to make it most like you're used to. You can change all kinds of stuff, so you can change your theme and whatnot, and the colors, and yeah, but there we go. So when we're doing this, we are going to be building this beam right here. And I'm going to go ahead and get started. So let's create a sketch. Doesn't really matter which plane, so I just chose one, but I'm going to sketch using the origin because that's always a good idea. So if we look up here, here are sketch tools. Yeah, that's a 2-point rectangle, but I want to do a center point. So if you click on the little drop down here, you can go to a center point rectangle. And if I look at my sizes, this is going to be 11.91 tall, 3.97 wide. So let's go ahead and hit the origin right here, and I just made one click. Now the easiest way to draw with Fusion is to use precise dimensions. So you can see as I'm dragging this out that height is highlighted, so it's kind of blue over here, and you can see that it says 11 point whatever. So I'm going to go ahead and type in 11.91. So I haven't made another click yet other than the origin, and we can see now that my height is locked in. So that's one of the cool things about Fusion. You can type in your precise dimensions, just like you can with Onshape. My width is 3.97. Now to switch between my height and my width, I have to hit the Tab key on the keyboard. So I'm going to hit Tab, and that'll switch. And we're doing 3.97. So again, that was Tab to switch between the dimensions. So I'm going to 3.97. And there's the outline of my I-beam right there. So that's the size of everything. Right, so in CAD, there's a million different ways you could model stuff. I'm just going to do it the way that I like. So next thing we see is the width of the web. So we can see TF, that's the width of the flange. TW is the width of the web. So let's do our web next, which is 0.2. So I'm going to get another center point rectangle right here. And we can see that my height is first. I'm going to make sure my height is the same, 11.91. And my width is going to 0.2. Okay, and there we go. So go ahead, enter. And there's my web. I know it's kind of confusing. There's a whole bunch of stuff going on here, but we do see some lines. I know there's all these dotted lines. That's kind of our construction lines and dimensions and whatnot, but we can see that I do have my web. So I'm going to pull out these dimensions just a little bit more just to show that they make sense. So I got my web, and I got my overall dimension here. So I can see that my flange has a width of 0.23. So I'm going to go ahead and move up here. So I'm just using my mouse to zoom. And if you click on the mouse wheel, you can pan. That's kind of like Onshape. So that's why it's useful to switch your mouse controls to Tinkercad. Right, so I'm going to go with 2-point rectangle now, and my width is 2.23. So I'm going to start from this top corner, and we can see that it's selecting that height, which is exactly what I want, because I want to make that 0.23. So we'll type that in, and now we can see that it's locked onto that height. Now I could type in that 0.397 for the width, but I can see that it's locked on that edge right there, so I'll just go ahead and click right there. And we're going to do the same thing at the bottom to get that other flange. So 0.23, so we'll get our corner point rectangle. I'm up, and I want to make it 0.23, just dragging in that direction to show which direction I want. And we'll come up here and click. And now we have pretty much everything we need. So I have my flange, I have my web, so it's time to just trim. So I'm going to trim off everything that I don't need. I don't need that. I don't need that. That. Just get rid of all this extra stuff. Get rid of that just to make sure. You can see blue is the color of my shape or my closed face. So right there I have my web, and I'm just going to check my dimensions. So we got 0.23 right there, 0.23, 0.2 width for the web. Okay, 0.397 is the overall width of the flange. We have the overall height is 11.91. That looks good. So we'll go ahead and finish the sketch. So you click on that green check, just like an Onshape, and we finish the sketch. So up here is extrude. So we're going to extrude, and the assignment tells us that we want a 10-foot section, which is a very common section. So we're going to hit a, oops, let me pull my thing down there, length of 10 feet, which would be 120 inches, and we can see, boom, pulls it out there. Exactly what we want, so we'll hit OK. All right, so I have my beam, and we can see the origins in the center, so if I wanted to assemble some of these or connect them, that would be a lot easier. All right, the last thing we have to do is apply a material, and the material that we are going to apply is going to be a steel. So we're going to do a ASTM A36 steel, which is a high-strength structural steel. So the way that we apply material is a little different. So in Onshape, we would right-click on our thing. Well, actually, it's pretty similar. So if we go over our bodies, I know it looks a little different, but we have our body one. That's this thing right here. And yes, I guess it is pretty much like Onshape. We're going to right-click, and up here we have physical material. And here's our materials. And what I'm going to do is structural steel. If I can spell it correctly. Iron wrought, structural, high strength. Maybe we'll try high strength steel. So we can see that we can search through here. High strength, low alloy. We're looking for structural steel. Or we could just, I guess, type this in A36. Let's see if we can just type in A36. If they have that here, A36. And we have steel standard structural, so it's right there. So what we're going to do to apply this material is just drag it over and drag it onto there. I'll right click on here and select objects. So we can see that it's applied there. So this is our A36 structural steel, which is a very common structural element or steel that's applied or used for building I-beams. So we have that material there, and that's going to be used for our structural analysis. So when we actually put some weights on this and do our static analysis. So there we go. Our I-beam, all in 9 minutes. Good job.